So my next question to you guys is, what about constructors? How do they fit in to the picture, if at all? Do they fit in? Are they part of the, in a sense, the paradigm or just a programming hack? Or are they actually part of what is needed in order for us to actually go and say, oh, we created a new concept, and this concept requires us to have constructors, just like we had to have information hiding or encapsulation. Constructors is something that has to, it's more than just an implementation hack. It has to do with actual idea behind data abstraction. And what does that mean? So there is something in the middle between the actual concept and the implementation. And what does that mean? If we look, for example, at the implementation of a class, right? So we have a class don't care. We have a class don't care, and we have a it's built with all kind of data. And an interface. Now this is our class. Now what happens is that for a class to be for some kind of data, to be consistent, notice the concept, it's called data consistency. The concept I'm talking about is data consistency. With the C at the end. Data consistency. What does that mean? Well, it means the following. Suppose, for example, that I have an integer. We all know, now integer is a bad example, but it brings forth the concept. Suppose, for example, that my integer is a number, right? That's what it is. Now, suppose that it can take up a value that's not a number. How could that be? You say every arrangement of bits is a number. True. Let's think of a second of a special computer that bits are allowed to have three positions. It could be a 1, it could be a 0, or it could be a nothing, right? It could be a nothing. Now, when you tell your computer some bits are 1s, some bits are 0s, and some bits are nothing, right? That could be. Now, if I go and I create an integer, and I take a word of memory, or half word of memory, whatever it is, 64-bit, 32-bit, whatever it is, machines, and I go and I say, okay, what do I have in my integer? So since some of the bits could be a nothing bit, then do I have a number? The answer to that is no. So notice that suddenly I have an inconsistent data, meaning you're claiming that A is an integer. Well, it's not. It's something else. Now, normally, since bits could only have two positions, right? They're binary, either a 0 or a 1. So whatever data you put in that word is always consistent because there's always only 0s and 1s. So I can always look at the arrangements of bits and say, oh, it says the following number, right? But when you have let's say bits that are allowed to be a nothing bit, if I had such a concept, then not every piece of memory can be interpreted as a number. Some of them will be nothing bits. And therefore, notice that my integer became inconsistent. So now the same thing is true for your data type. If your data type claims that it has certain characteristics, somebody has to make sure that those characteristics are actually there. Meaning to say that if you claim that your queue begins with three pieces of data inside, and the data is 1, 2, and 3, suppose that's your data type. I'm just throwing something in the air, right? You start with a queue that has 1, 2, and 3 in it. Why? I don't know why, but that's your data type. So when you create a queue, it does not have a 1, 2, 3 in it, then that's not your data type. It's something else. It's nice that it does it pushes and it pops and does other things, but that's not your data type. Your data type was a queue that began with a 1, 2, 3. Therefore, we need something that takes the actual implementation and aligns it with the concept. Meaning to say that if you created an abstract data type that has a queue beginning with a 1, 2, and 3 in the beginning, so therefore when you create that queue, something has to make sure that the data is consistent and it has a 1, 2, 3 in the beginning. Now, from now on, it's your job to make sure that it doesn't go out of consistency. So your API to your data type have to make sure that it doesn't go out of consistency. Now, the assumption is that your implementation will make sure that it doesn't go out of consistency. It has nothing. The implementation has nothing to do with the abstract data type. But in the beginning of time, when the object begins its life, something has to make sure that it's consistent with the abstraction that we're trying to portray. Now, it's true that on a theoretical level, I could have done without it. On the practical level, you can't do without it because somebody has to make sure that happens. So it lies somewhere in between the theory concept and the implementation. It's not like I can do without it. I can't do without it because the data will be consistent. But on the theory level, I can assume the data is consistent. So on the theory level, I can say I can do without it. Practically, you cannot do without it. And therefore, it lies somewhere in the middle between the theory and the implementation. It's not an implementation hack because it's not just a matter of, why do things twice? Or let's save memory, or all those kind of things. It's much more than that. It's there to create data consistency. It's there to make sure that the actual data that we have in memory is consistent with the theoretical description, with abstraction that we're talking about. That is the purpose of constructors. The idea is that I don't care how it's implemented. Notice, I'm still not dealing with the actual implementation. I am still saying that you need something to make sure that however it's implemented, whichever way you choose, which is something which is hidden from me, that's information hiding, is consistent with what the abstract data type is supposed to represent. So it's not just a hack thing that let's save memory or whatever it is. It's coming to say, I need to go and notice again without talking about implementation. I don't care how it's implemented. But the idea is that however you implement it, make sure that implementation is consistent with the abstract data type.